In this learning module, we will experience a quick overview of the tools which are provided within the TIBCO Spotfire environment specifically for the purposes of multivariate data analysis. These computational tools include line similarity, k-means clustering, and hierarchical clustering. The first question you may have is, what do you mean by multivariate data? Well, multivariate data can be found in data tables originating from many different industries where TIBCO Spotfire is used for analysis. In simple terms, multivariate data occurs anytime you have an item which is measured or defined by multiple numeric values. These items could be molecules being tested for drug development, the customers of a business, oil wells or oil fields, genomic or proteomic constructs, subjects in a clinical trial, members of your sales team, survey respondents, geographical regions, projects, products, and the list goes on and on. Let's begin with a discussion of what the line similarity tool can do with this type of data. If multivariate data is displayed in a line chart, the line similarity tool will apply a series of pairwise comparisons where all the lines in the line chart are compared to a specific master line. With the results of these calculations, you can easily filter to isolate lines which are similar to the chosen master line. We will discover that there are three ways to define the master line for this comparison: marking a single line, marking multiple lines, or selecting from a list of preset patterns. Concepts learned in the line similarity module will spill over to our discussions about k-means clustering. But more about that in a moment. First, let's open a demonstration example where line similarity has already been applied to a line chart in a Spotfire analysis document. Use Open File and navigate to the example with Multivariate Overview in the title. Click Open and agree to the terms and conditions of use. The data table supporting this analysis collects purchase information from 754 customers at a Megamart department store across 7 different departments. On the page titled Line Similarity, a line chart has been created which displays those purchase patterns for each customer. For example, this customer has made the highest purchase amount in the furniture department, but has also spent a large amount in the groceries department. From these 754 customers, one has been singled out as our prime furniture shopper. Because we were interested in isolating other customers with a pattern similar to this customer, the line similarity tool was applied, and this filter was the result. We can use the slider to limit the customers in the visualization to only those who were ranked more similar to our prime furniture shopper. And you can see the patterns of interest emerge from the dense fog of lines in the plot. Let's reset the filter and look at another subgroup of customers. Our Price Club members display this array of purchase patterns. Because we wish to identify other customers with purchase patterns similar to our Price Club members, the line similarity tool calculated the average purchase pattern from these lines and returned this column of data. We can use this filter to isolate the 30 patterns which are the most similar to that average. And it's no surprise that some of the Price Club members identified with blue lines remain in the line chart. We could isolate other customers by using this filter, and only gray lines remain. Let's reset all filters and examine this final column. A third line similarity calculation was applied in order to rank patterns compared to the imaginary line represented by the minimum value across all departments. Sliding this slider to the left will isolate the lines which represent our minimalist shoppers. Returning all lines to the line chart, the line similarity tool is only one option for bringing order to this mess of lines. Another option is to apply k-means clustering. On the left, you can see the original line chart, and on the right, you can see the same lines after k-means clustering has been applied. Hopefully, it is obvious that similar patterns have been grouped together into one of our 12 cluster groupings. The Filters panel shows the primary output from the k-means clustering calculation, a column of cluster assignments, which has been applied to trellis the line chart. The easiest way to explain k-means clustering is that it employs the same similarity calculations available in the line similarity tool toward the goal of dividing a line chart into trellis panels based upon line similarity. The nice thing about k-means clustering is that it's very easy to initiate. All you have to do is create a line chart and select a distance measure and a number of cluster groups to create. The other clustering technique, which is built into the TIBCO Spotfire Analyst environment, offers more options but may take a little more consideration to understand. Hierarchical clustering is a process for organizing multivariate data, which also employs similarity calculations. The results of this type of clustering are generally expressed in the form of a heat map, where column dendrograms and/or row dendrograms relate the similarity results of the clustering process, and sort the data in the heat map in order to reflect those similarity groupings. In order to effectively use the hierarchical clustering tool, you will need to know a little bit about the distance measures, or similarity calculations, which are available within this tool, and the clustering method options which can be applied. You should also be aware of the impact ordering weight has on heat map sorting, and the fact that normalization and empty value replacement can be performed on the data prior to executing similarity calculations. In fact, the final two items on this list are also considerations when applying line similarity and k-means clustering tools, as well as hierarchical clustering. Therefore, prior to performing any similarity or clustering analysis, you should consider whether the data has any empty values, or whether normalization should be applied in order to make data ranges comparable or control for factors which influence the variability of your data. Let's return to our demonstration in order to take a look at the same customer data organized with hierarchical clustering. A row dendrogram has been applied to this heat map, and the length of the brackets are an indication of the level of similarity between rows. Shorter brackets in the dendrogram mean more similar rows. The dashed pruning line can be positioned at different levels of similarity in order to divide the rows of the heat map into clusters, identified by alternating colored dendrogram branches. In addition, you can see the row cluster IDs filter adjust to show the number of unique values, which is indicated by this value on the pruning line. If we adjust the pruning line to divide the heat map into 3 clusters, we could use this filter to isolate one of the clusters of interest and evaluate the purchase patterns for this group of customers. Take note of the information displayed here in the legend, which reiterates the various settings with which you will need to become familiar in order to effectively use Spotfire's hierarchical clustering capabilities. These include clustering methods, distance measures, ordering weight, normalization, and empty value replacement.